Welcome to the solutions to the Regents Physics Static Electricity problem set, problems number 7 through 10. Let's go ahead and get started with number 7. We have two charges, QA and QB, separated by a distance r, and exert a force F on each other. What new force will exist if, and they give you 5 different scenarios of factors that are changing. What I recommend for you in doing these types of problems is that you start with the equation that relates all the variables, which of course is Coulomb's law. Fe equals K. In this case, the Q1 and Q2 become QA, QB over R squared. Leave a space in between any of the variables that could change, and then use that and make the necessary changes described in each one. For example, in A, they say QA is doubled. Well, if you double QA, Fe is directly proportional to the product of QA and QB. So if you double QA, that means you also double the force. And so the answer to A is F is doubled. I'm going to give you the rest of the answers here for B, C, D, and E. If you do not understand why these are the answers, make sure you ask in class tomorrow. So for B, if QA and QB are cut in half, F would end up being 1/4 as great. If R is tripled, F would be 1/9 as great. If R is cut in half, F would be 4 times greater. And if QA is tripled and R is doubled, that would be an impact on F that is 3/4 its original value. All right, let's move on to number 8. How many excess electrons are on a ball with a charge of -4 times 10 to the -17 coulombs? And this problem is asking and referring you to the New York State reference table. On the reference table, you'll find that 1 electron has a charge of 1.60 times 10 to the -19 coulombs. And of course, negative because it's an electron. So if we take the charge, that's the excess charge, -4 times 10 to the -17, and divide by the charge of 1 electron, this will give us the charge, this will give us how many electrons make up that charge. So 4 times 10 to the -17 divided by 1.6 times 10 to the -19, and you get 250 electrons. In number 9, a strong lightning bolt transfers about 25 coulombs to Earth. How many electrons are transferred? In this case, there's a conversion on the reference table that tells you how many electrons 1 coulomb is. In the previous problem, it was how many coulombs 1 electron is. In this one, it's how many electrons 1 coulomb is. And again, both these conversions are on the front page of your reference table. So we have that 1 coulomb is 6.3 times 10 to the 18th electrons. So if we multiply that by 25 coulombs, coulombs would cancel, and you get 1.6 times 10 to the 20th electrons. Number 10, 2 electrons in an atom are separated by 1.5 times 10 to the -10 meters, the typical size of an atom. What is the electric force between them? This, of course, is a Coulomb's law question. F equals K, Q1, Q2 over R squared. We sub in Coulomb's constant, or the electrostatic constant as it's known, 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. It's an electron, so it has a charge of -1.6 times 10 to the -19. This could be 1.60, by the way. There's another electron, so it also has a charge, -1.6 times 10 to the -19 coulombs. And they're separated by 1.5 times 10 to the -10 meters. And don't forget to square that, most common mistake in doing this calculation. Go ahead and perform your calculation, and you get a magnitude of 1 times 10 to the -8 newtons. And because they're electrons, negative repels negative, and so the force will be a force of repulsion away from each other. That'll do it for our solutions to 7 through 10. More practice with Coulomb's law when we do problems 11 and 12 in class tomorrow.